Today we're going to look at matrices, a little bit of an introduction, as well as look at adding and subtracting and using scalar multiplication. All right, so first, what is a matrix? So, a matrix is a rectangular arrangement of numbers organized into rows and columns. So here we have a graphic that shows a chart. If we were to create a matrix to represent this chart, keeping the same rows and columns that the chart has, we'd say, all right, if we're going to aim to put our t-shirts as row 1, each element or value within the chart has to line up with a row and a column. So t-shirts that are large would be a net value of 10. T-shirts that are extra large would be a value of 15. Our next label would be sweatshirts if we wanted to match the graphic. Where under large we would place 8 and under extra large 12. Now, in the ones you're going to do in your homework, they're not going to have labels like this out to the side or above. However, I just want to give you the general gist of what the purpose of our matrix is. So last but not least, we have long sleeves. Which is a 14 for large and a 5 for extra large. So when you write out your matrix, if you're drawing it on your own, you have a spot for each element. You leave enough space so you can tell where one element ends and where one begins. And then we put this set of parentheses around the whole thing. Not really parentheses, I should say brackets. Apologies for that. Put this set of brackets around the whole item. Now, the dimensions of a matrix are going to be rows by columns. Now, this is important because the rows and columns of a given matrix will determine if it can or can't be added together. And how that looks should also kind of play into if it can be multiplied when we get to that chapter, or when we get to that lesson. So if we were to give the dimensions of this matrix that we just did over here on the left, it has 3 rows and 2 columns. And you don't multiply this. It's like giving the dimensions of measurements for like a board you would use in construction. You just say it's this by this, and you do not multiply that out. If you like to actually put the word by in between, you could. So let's practice that first before we get into adding our matrices. So here, a row goes left and right. A column is up and down. So this has 1 row and 3 columns. So it's a 1 by 3. This next one has 3 rows and 2 columns. So we would say it is a 3 by 2, just like our original one there. And then last but not least, and again, feel free to pause if ever you want to kind of test this out on your own before you hear the answer. This one has 2 rows and 1 column, so we would say it's a 2 by 1. All right. So the reason we covered that first is because the operations that we're going to cover today are adding and subtracting. And the only way to add and subtract a matrix is if the 2 matrices, or however many there are, if they have the same dimensions. So here we're going to put the word same. So you want to check for that first. If you come across something where that is not the case, you will just say cannot be done or not possible. All right, so as we combine these using addition and subtraction, we are going to combine elements that are in the same position within the matrix, which is why we have to have things with the same dimensions so that all of the numbers pair up with another number. All right, so example 2. On A, we are adding. So I'm going to kind of do an in-between step before my final matrix to show you which items are being combined. So I'm going to kind of do a little bit of color coding here. So 2 is in the first row, first column, as is 4. So when we add these together, that top part of our final should be the result of 2 plus 4. Which is 6. So my final matrix, that'll be my answer, and you don't have to do the in-between matrix if you don't want to. I'm just going to do it for purposes of showing you what's being added or combined. So I'm going to switch up colors, keep this color coded. So row 2, column 1 is 1 and negative 1. So the result of that addition will be the second part of my matrix, which should just be a 0. And then last but not least, we'll do 3 and 5. Which should give us an 8. And that is the final answer. So again, I've color coded it so you can see where the items that are like sit, so they're sitting in the same location within each matrix. They get combined using the operation that's in between the two matrices, giving us our final answer. Now, this can get tricky when there is a minus sign. So I'm going to do one additional step before we go ahead and combine them together, and that's going to be to distribute this minus. So using our subtraction rule, anytime we have subtraction, we can always change it to positive, and then we change everything in the parentheses or in the matrices in this case that's after it to the opposite. So I'm going to change everything here to the opposite. I'm going to write this in so we know. We're going to add the opposite. So we're going to go minus, minus, plus, and minus. Then we can go to our solution matrix. So I'm going to take 4 plus a negative 1. I'm going to take a negative 1 plus a negative 2. We'll do 0 plus 2. And then last but not least, 5 plus a negative 3. So if we go ahead and evaluate all of those, we should get 3, negative 3, 2, and 2. And there's our answer. Again, if you want to pause so you can do this third one on your own and then you can check it once you're done, feel free. So I'm going to look at the dimensions of these. We have a 2 by 2 and a 2 by 1. These do not have the same dimension. So our result here is that this is not possible. All right. Now, one other thing we're going to cover today is multiplying by a scalar. And this is different than actually multiplying matrices together. So you may be wondering, what's a scalar? A scalar is just a real number that you can multiply to each entry in a matrix. I'm going to adjust the wording of that. It's kind of like distributing through a set of parentheses. So if you see a number sitting out here in front, that is your scalar. And your job is to multiply that to each item or element within the inside to complete that operation. So for example, 3a, let me go ahead and put my brackets in. If I take a -1 times 3, I would get a -3 in row 1, column 1. A -1 times 0 is still 0. That's row 1, column 2. -1 times -2 is 2. That's row 2, column 1. And then last but not least, -1 times 1 is -1. So again, just like the distributive property, you're going to take it and multiply it to every piece inside your matrix. So here we're going to take everything times 2. We should get -2, 8, 0, 6. It's a pretty quick process. What this eventually leads to is doing a combination of multiplying and adding and subtracting depending on what the problem has, keeping in mind our order of operations. So depending on where parentheses might land, I don't have parentheses on this one, you want to do inside your parentheses first. You shouldn't come across any exponents. Then you would tackle your multiplication. Then you would tackle your addition and subtraction. So that's kind of what you could expect to see when doing this in your homework. So here we don't have any parentheses, so I'm going to go ahead and multiply first. And in doing so, I'm also going to kind of take care of that negative. So let me just rewrite my first matrix. It's just kind of waiting while we multiply by a -4. I'm going to go ahead and multiply by a -4 so that I can eventually just add these two things together. So I'm going to, in essence, add the opposite while multiplying. It's going to kind of do that process for us. So we should get -4, 20, -16, and -8. All right, then we add. 0 plus a -4 is -4. 4 plus 20 is 24. -5 plus a -16 is a -21. And -6 plus a -8 is a -14. And feel free to use a calculator if you think you need it. You could end up working with quite a few negatives, so if that makes you nervous, feel free to pull that out. And we're going to go ahead and skip example 5 on these notes. So that should get you through lesson 11.1.